Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the SAT Official Study Guide 2020. If you do not own this book already, purchase one immediately. You're going to need it. Today we'll solve some problem that you will find on page number 1136. Page 1136, please turn to it. Always make sure the book is in front of you so that you can read the problem yourself. So here's the gist of the problem. Here's the nub of the problem. Number 35, very first one there. It says that we're going to have ratings from 0 to 100. Apparently, a consumer, an online survey, the consumer satisfaction survey is being conducted, and they're going to rate the firm from 0 to 100. We are told that the average of the first 10 numbers is 75. Question is, what is the least possible value of the 11th survey if the average of the first 20 is at least 85. There you go. So clearly we are dealing with an inequality. So let's set it up, shall we? So we're going to set it up in terms of numbers so it's easier to see. So we have 20 surveys altogether. It's starting from survey number 1 all the way up to survey number 20. We are told that the first 10 surveys right up to here, first 10 surveys, we are told that the average of the first 10 surveys is 75. If the average of the first 10 surveys is 75, then it must be 75 times 10, the number of points that are earned on those 10 surveys. 11th one is the one we want to find. This is the unknown. This is 1 through 11, 1 through 10. 11th one is the unknown quantity. We also know that 12 through 20 is going to be 9 surveys, and we also know that the highest possible rating that the firm can earn is 100. That's the highest possible. And since we want 11th to be the least possible value, what's the least possible value that I can have and still be able to maintain an average of 85 over the 20? Well, the only way you can achieve that, the average of 85 over the 20 surveys and still have the least possible value that you can possibly have, is to have the maximum value, or the most possible value. I was going to say there is no such thing. The maximum value that you can have in these 9 surveys, 12 through 20, 12, 13, 14, all the way up to 20 years, and that's 100. That's the most that we can earn. There you go, we are done. So that's going to give us 900 points. This is going to give us 750 points. And this 11th is the unknown quantity. Let's drop an arrow down so we can follow it. This is the 11th one. That's the unknown quantity. And some of these points that we earn has to have the average of at least 85, which means it has to be greater than or equal to 85 times 20, because there are 20 surveys. I think we're talking too much here. It's very simple actually. That's all it is. 8 times 2 is 160, 1600. 80 times 20 would have been 1600. We don't have 80 times 20, we have 85 times 20. 85 times 20 would be 1700. Greater than or equal to 750 plus 900. And let's see, 750 plus 900. 750 plus 1000. 750 plus 1000 would have been 1750. So 750 plus 900 would be 1650. So x plus 1650. There we go. Continue here, subtract 1650 from both sides. Oh, there you go, we're all done. So here the x part, x, this is going to cancel out, has to be greater than or equal to 1700 minus 1650. Very good. As long as we achieve a survey rating of at least 50, we'll be able to achieve our goal. Our goal being the average rating of 85 over the 20 surveys. In order for us to do that, we have, for the next 10 surveys, 11th through 20th, the last 9 we must achieve the maximum possible values of 100, in which case even if we get a 50 rating of 50 on the 11th one, we are fine. Let's do the next one. Number 36. In number 36, again we are dealing with inequalities. Two very simple, very straightforward inequality. Let's see what they say. So we are told that y is less than or equal to negative 15x plus 3000, and the other one says y is less than or equal to positive 5x. We are told that the point with the coordinates AB, a point with the coordinates AB lies in the solution set. Lies in the solution set. What we want to find out is what's the maximum value of D. In other words, if you're looking at a point that lies within the solution set of these two inequalities, then what's the highest possible value of the y coordinate of such a point that lies within the solution set? Let's see what we can do. As always, it helps to have a picture in front of us so that we can visualize it as opposed to just doing it in our head. So let's draw the two inequalities here. Now when I say let's draw the two inequalities, you have to understand that we're not going to actually sit there and draw to scale. We just want a rough sketch, some idea of what's going on here. So that's very straightforward. First inequality, we can clearly see it as a negative slope, so it's going to go negatively slope. Second part that we notice is that when x is equal to 0, y is equal to 3000. When x is equal to 0, y is equal to 3000, that's all we need. So when x is 0, y is 3000, somewhere here, I'm going to put it way up there. Let's say this is 3000. As I said, it's not drawn to scale. It doesn't have to be drawn to scale. Just draw a line. It has a slope of negative 15. And that's this inequality right here. Let's make a note here. This one is y is less than or equal to negative 15x plus 3000. Now we understand, if I were taking the exam myself, if this were a real exam, and if I were doing this question myself, I wouldn't have wasted my time writing this out that way that I just did here. A lot of things we do here just to make it easier for us to see what's going on, which is why it takes a while, because I'm explaining too much. Let's draw this one. Again, straightforward thing. This was a positive slope. When x is equal to 0, y is equal to 0. It goes through the thing. This had a negative slope, negative 15 slopes. It's very steep. This is a slope of 5, so we're going to make it very shallow, going through the intercept. There you go. Going through the origin rather. There we go. As I said, there's no need to make a fuss about it. This is where the story begins. This is where the story begins. Pay attention here. Had this been y is less than 5x, then instead of drawing a solid line, we would have drawn a line like this. In other words, all the points that lie on this line are not part of the solution set because it is not equal. It is not equal to y is less than 5x. But in fact, what we are dealing with here is that y is less than or equal to. Let me do it in a different color so we can emphasize it. Y is less than or equal to. Similarly here, y is less than or equal to. In other words, all the points that lie on these two lines are also part of the solution set. So let's make it a solid line one more time. And we are looking for a point that lies within the solution set. Before we worry about that particular point, let's talk about where our solution set lies. The first one said y is less than negative 15x, so that's this part right here. Let me erase this 3000 because it's annoying. I'm going to erase this 3000. I'm also going to erase this thing, it's getting too crowded. Okay, I'm going to speed up, I'm going to pick up speed here. Here's the solution. Here's the first part. And the second one says y is less than 5x, which is this positive slope line, so this is right here. And the solution set includes this line, this solid line, and this solid line. And all the points that fall within the solution set, we're looking for one point such that the y coordinate takes the maximum possible value. If you look at all the points, the point where you can have a highest value of the y coordinate, is right here. Right here. Where the two inequalities intersect. And that's all it is. And for some of you, and for those of you who understood this right from the very beginning, if you understood this concept right from the very beginning, all the time that we spent so far was unnecessary. If you're able to see immediately that that's what we're looking for, we just set them equal to each other. Negative 15x plus 3000 is equal to, because that's where they intersect, 5x. And that's all there is. Bring the 15x to this side. If you bring the 15x to this side, we'll end up with 20x is equal to 3000. Divide both sides by 10. There we go. 2x equals to 300. X is equal to 150. Now, don't be hasty. Don't be hasty. X is the A value. This is the A. This is the A we have found. We're not interested in A. We want to find out what the value of B is, which is very simple. If X is equal to 150, then Y, we can use either one of these two inequalities. And since this one is easier to use, I'm going to use this one. Y is equal to 5x, which is same as 5 times x, which is 150. And that is 750. In other words, the coordinates of these points are, this is one, from here to here is 150, which is not what we're interested in. We're looking for the vertical distance right here, and that is 750. And that's our B. The maximum value of B is 750. So make sure that you pay attention, and always pay attention to all the nitty-gritty, especially when you get towards the end of the sections, because as you get to the end of the section, they get a little bit more tricky. The math does not become complicated, it's just a matter of paying attention. We don't want to find out that you did all the work here and you stop right here and you graded in 150. That would have been wrong. That's the x coordinate. That's A. That's A. They're asking for the maximum value of the y coordinate, which is 750. Number 37, the penultimate question. The penultimate question, we'll worry about that in a second. Number 37. It says that n is equal to r times t. R represents the number of shoppers per minute. And we're told that's what R represents, and T represents each shopper spends an average of T minutes. So here somebody has devised, some marketing person, some marketing genius has come up with this discovery that if you want to estimate how many people there are, how many customers there are in the store at any given point in time, this is the formula that you can use. R represents how many shoppers per minute that walk in the store, and how many minutes on average, this should say on average, not on average, number of shopper, on average, each shopper spends on average T minutes. So if you can estimate that part, you can figure out how many shoppers there are in the store. For example, in store A, we are told that an average of 3 shoppers enter per minute. An average of 3 shoppers enter per minute, and each spends about 15 minutes. Well, that's very straightforward, which means that since n is equal to r times t, and we know that 3 shoppers enter per minute, that's our r, and on average they spend 15 minutes, which means in store A, we'll have about 45 shoppers in the store at any given point in time. This tells us that there are, this is 45, this tells us that there are 45 shoppers in the store at any given time. What I left out is the statement, the qualification here. There are, on average, on average 45 shoppers in this store at any given time. So if you were to take a random sample of, say, 5 different occasions or 10 different occasions in the course of the day, and counted how many shoppers there are in that store at that time, you will find that on average there are 45 shoppers, because 3 shoppers are entering every minute, and each shopper spends about 15 minutes in the store. Let's begin. The question is not begun yet. This is just a setup. Number 37 has not begun yet. Now we're going to do 37. But this thing, what I'm calling store number A, which we just found has 45 shoppers on average. This information is very important because we're going to need this information about store A. Even though the question does not call it store A, I'm calling it store A. Whereas number 38, they're going to introduce another store, and we're going to have to we are asked to compare the 2 stores. So I'm calling this store A, and the one that's going to appear in number 38, we're going to call it store B, so that we can keep our work straight. Let's begin. I keep erasing that word, and I'm tired of rewriting it. Let's learn. Penultimate simply means, the word penultimate simply means second to the last. The problem that we're doing right now is the second to the last problem in the section. It is the penultimate problem, a word that we learn in our vocabulary lessons on day number, well, give me 1 second and I'll tell you when we learned it, because I do know we learned it, because I use it all the time, and which is why I covered it in the vocab lesson. There you go, day number 11. If you want to improve the vocabulary, I see no reason why you wouldn't want to, because you want to get a decent score in the verbal part. Watch the vocabulary videos on my channel. Just type in SAT vocabulary words day 1 and watch those videos. Or better yet, visit my website keshwaniprep.com, and there you will find the links as well. Well, let's get going. Number 37. We are told that the same equation, this equation right here, n is equal to R2, which we used just a little while ago to do the analysis on the whole store. We are told that the same equation can be applied to estimate the average number of shoppers at any given point in time, not in the whole store, but it can be used to estimate the number of shoppers at any given point in time in a given department in the store, one department within the store, or even a one checkout counter. I'm not going to write all of that down, but that's what it is. Okay? So here we're dealing with the checkout counter. We are told that 84 shoppers per hour, this is per hour, make a purchase. And each spends about 5 minutes in the line. So this we are dealing with checkout counter. Each spends on average, it should say on average, I'm just calling it about, that's what it is. They estimated it, they found out that each shopper on average spends 5 minutes in this particular checkout line, and the question simply is, how many shoppers are waiting in the line at any given point in time? And that's your N. How many shoppers are waiting at any given point in time in the line? So let's find out, shall we? So here we have 84 shoppers per hour, per 1 hour. But that's not what this formula is. This formula here, R represents the number of shoppers per minute, not hour. So we have to convert this hour into minute. In other words, we have to divide by 60, which is exactly what I'm going to do here, because we know 1 hour is made up of 60 minutes, obviously. The hours are going to drop out, and we have to divide 84 by 60. 84 by 60. Let's divide top and bottom by 6. If we divide top and bottom by 6, 60 is going to become 10. And let's divide the 84 by 6. 8 is made up of 1 6. After we take away 6 from the 8, we have a remainder of 2. What happens to the 2? 2 goes and joins the 4 and becomes a 24, and 24 has 4 6s. There you go. 14 divided by 10. 14 divided by 10 gives us 1.4 shopper per minute. 1.4 shopper per minute. Now we can pick up from here. So now we have the value of the R, 1.4 shoppers, 1.4 shoppers per minute, shoppers per minute, and this is, T represents the number of minutes each shopper spends in the checkout counter, which we are told that each spends approximately 5 minutes. As you can see, the minutes drop out, and what we're left with is the shoppers. How many shoppers can we expect? How many shoppers can we expect to find in this particular checkout line at any given point in time? The answer is 1.4 times 5. We know 1.4 times 10 would have been exactly 14, so it's 7. N is equal to 7. In other words, in this particular checkout counter, on average, we expect to find 7 lines waiting in the line. 7 people waiting in the line. Let's do the next one. Number 38. Give me 1 second, 1 brief second. In number 38 introduces a different store which, for our convenience, so that we can keep the two separate, for our convenience, we're going to call it store B. In store B, we're told that average of 90 shoppers per hour enter the store, and each stays on average about 12 minutes. The question is this. Now we have to understand that because we're dealing with the very last question in the section, it will have many twists and turns. It will not be straightforward. The math is not complicated. Math never is. It's just twists and turns that you have to pay attention to, that we need to concentrate. We'll have to do several, in other words, we'll have to do several steps before we get to the very end. And that's the definition of hard question in the SAT. Hard question is not hard because it involves calculus or differential equation. It's hard because it has more steps. That's what it is. So here's the question. Average number of shoppers at any time in store A, in store B, this store that we're dealing with, is what percent less than the average number of shoppers in store A. And we already know, we made a note of it last time, that in store A, the average number of shoppers in store A is 45. That we know from what was given to us. This information is given in the problem, in the beginning of the two problems. We just have to figure out the average number of shoppers that we can expect to have in store B in the new stores, and once we have it, all we have to figure out is that number is what percentage less than 45. Do you understand? Let's find out. 90 shoppers right here. 90 shoppers each hour. So to divide by 60. Hours is going to go out. Shoppers per minute. Divide top and bottom by 0. 9 divided by 6 is 3 halves. There you go. 3 half shoppers per minute. Let's put it on the top here. And each stays on average 12 minutes. There you go. So we're dealing with store N and the store B rather, and we just found out this is 3.5 shoppers per minute, and each stays, we are told that each stays 12 minutes. There you go, we're almost done. So 2 is divided into 12 6 times, 3 times 6 is 18. There we go. So now we're comparing 18 versus 45. We're still not quite done here. Let's make sure that we pay attention. Oh, I shouldn't have erased this part. The question was, I shouldn't have erased it. I'm going to read it to you. It was there. It says average number of shoppers at any given point in time is what percentage less? Is what percent less than 45? Because that's what this is. Now, if you take out this particular part, it's a different question. They're not asking us 18 is how much less than 45. 18 is what percentage less than 45. Let's first find out 18 is how much less than 45. This is 45. This is 18. 15 minus 8 is 7. 3 minus 1. Oh, there you go. So now the question is 27 is what percent of 45? That's what we're looking for. 27 is what percent of 45? Because 18 is 27 less than 45. And the question was 18 is what percentage less than 45? Before we worry about 18 is what percentage less than 45, we first figure out 18 is how much less than 45. 18 is 27 less than 45. Now we're done. It's just 27 over 45. 27 over 45. We are almost done. Divide top and bottom by 9. If you divide top and bottom by 9, this becomes 3 and this becomes 5. There you go. It is 3/5, which is 60%. Average number of shopper in the new store that we opened, store B, on average, and that store in store B, we expect to have about 60% less shoppers than the number of shoppers we expect to have at any given point in time in store A, the old store. That was it. That was the end of the section, and obviously we're going to stop right here. If you wish to get hold of me, you can reach me by visiting the website keshwaniprep.com. There you will find a link to the email. You will find forms to fill out if you like, with your information on what exam you're preparing for and so forth, and we'll talk at that point. In the meantime, I'll see you next time in the next video, where we'll start the very last exam, exam number 8. Alright, bye now.